Okay, so for this experiment, you're gonna need a ping pong ball, a straw, and then a hair dryer. I know in the script we also mentioned that you can use a water stream, but that's a little harder to pull off, so I think we're just gonna skip that for this experiment. For our purposes, the straw and the hair dryer should be fine. So what you're gonna do first is you're gonna obviously plug in your hair dryer, but once you do that, you can start off with the experiment with the straw. So what we're gonna be demonstrating here is something called the Coanda effect. And essentially, it's the tendency for an airstream or like a jet stream to stick to a convex surface. In this case, our convex surface is going to be our ping pong ball. And the way to actually do this experiment is just start off by blowing into one end of the straw. You're going to tilt the straw upward, and then you're going to place the ping pong ball on the other side and just blow as hard as you can. And what you should see is that it will stay in place in a stable position without falling, as many people would expect it to. So I'm just going to show you that. So obviously that did not last very long. I don't have great air support, but you should be able to get it to work for at least a few seconds, and that's what you just really need to show the kids for this experiment. The way to make it last a lot longer is you're going to be using the hair dryer, and it's pretty much a similar process. You're going to turn on the hair dryer, and then you're going to place the ping pong ball on top, let it sit there. You can also tilt the hair dryer a little bit to see that it will still stay stable as it's going in a different direction. So one way you can do the hair dryer experiment too is just to tilt this around a little bit. You should see that the ping pong ball should still remain in a stable position. That's because of the Coanda effect. So how does this effect actually work? Basically, as fluid travels in a curved path around an object being deflected, such as this ping pong ball, the air is going to be deflected off to the side, and then it's going to create pockets of low pressure because of fast moving air. And then as the air particles travel around the ping pong ball in all directions, it basically traps in a column of air, which is what you see with the hair dryer. So pretend there's a big stream of air coming up. The ping pong ball is going to be trapped in that column of air. If it moves to any direction, it's going to create a pocket of low pressure on the other side because of fast moving air. That low pressure is going to pull the ball back to the center, which is what keeps it stable. If the ping pong ball moves at all, like I said, fast moving air creates a pocket of low pressure that brings the ball back to the center. So it's still in a stable position no matter what. Essentially, how it stays floating is because gravity is trying to pull the ball back down, but the fast moving up is keeping the ball suspended in the air. And then the fast moving air on either side is what keeps it stable in a stable position. It works very similarly with the straw, just slightly different. Instead, what you see here is the Coanda effect, where basically the stream of air wants to stick to the ping pong ball because it's a convex surface. And that essentially is how these two experiments work. So good luck.